Okay, Unit 8 review. Number 1 says, which of the following best represents the square root of 74? So first, find the square root of 74, type it in your calculator, and you should get 8.6. So that means it should fall somewhere between 8 and 9, kind of in the middle. So looks like A is the only one that shows that, between 8 and 9. This one is between 9 and 10, 7 and 8, 10 and 11. So A's got to be our answer. Number 2, which of the following has a value between 8.91 and 9.60? So take a second, go through there, and solve for all of these. Find the square root of 70, square root of 80, square root of 93, and square root of 105. Okay, so if you go through here and solve for these, you've got square root of 70 is 8.36, 8.94, 9.64, and 10.25. So the only one in that range of numbers would be B. You could kind of know 105 is a little too high already. Number 3, the hypotenuse, that's our C, of a right triangle measures square root of 35.35 meters. Which of the following is the best approximation of the length of the hypotenuse? So type in your calculator the square root of 35.35, and you should get 5.945. So if we round that up, looking at my answer choices to the nearest hundredth, that should be 5.95. Number 4, a model of the Pythagorean theorem is shown below. Based on the information in the model, which equation represents the Pythagorean theorem? Remember, it's a squared plus b squared equals c squared. So c is always our longest side, or our biggest number. A and b are interchangeable. One thing we need to notice about this is saying 25 is the area. So it's already multiplied side by side. It's already multiplied base times height. So we need to find the square root of that. The square root of 9, the square root of 16. Because it doesn't give us the side lengths, it gives us the entire area. So we have to find the actual side lengths. So the square root of 25 should be 5. The square root of 16 would be 4. The square root of 9 would be 3. So it should be, since A is 3, 3 squared plus 4 squared equals 5 squared. Number 5, when his bus arrives, Calvin is 40 feet east of the corner. The door of the bus is 30 feet north of the corner. So here's our corner, here's little Calvin. He's 40 feet east of it and 30 feet north of it. Approximately how much further would Calvin, how much further? So that tells us we're going to be subtracting. Would Calvin travel by walking on the sidewalk, which is this path we just kind of laid out here to here, to get to the bus? Then he would walk by walking across the field. Okay, so his paths are to take the sidewalk, so he would go 40, and then he would go 30, or he can cut across this field here. So first let's see what the field length would be. So it's still the Pythagorean theorem. Anytime you've got a right triangle, you know you're going to be using the Pythagorean theorem. So A, we can do 30 squared plus 40 squared equals c squared. So 30 squared plus 40 squared is 2,500. So then we want to take the square root of that, and we get 50. So if he cuts across this field, that's going to be 50 feet. If he takes this path on the sidewalk, he would go 40 feet plus 30 feet. So altogether, the sidewalk would be 70. So we want to take that 70 that he would take on the sidewalk and subtract the 50 if he takes that shortcut. And we get 20. So 20 feet farther. Number 6, which triangle is a right triangle? Remember, to determine that, we use that Pythagorean theorem, a squared plus b squared equals c squared. And the whole point, just like on that worksheet we did the other day where we were shading in, or you were doing contrasting colors for right triangle, not a right triangle. So you're determining if a squared plus b squared, whatever number you get for that, is the same as c squared, then you have a right triangle. If not, then it's not a right triangle. So first thing, go through on all these triangles, figure out which is your c, because that's off by itself, and if you get those mixed up, then your whole answer is going to be wrong. So for A, the c is our longest side or our biggest number, so it should be 80, in this case 15. For B, it'll be 9, and D, it'll be 9.7. Okay, so then set these problems up, and we want to see, so for A, we want to see if A squared plus 4 squared equals 80 squared. Just some common sense, just eyeballing. There's no way 80 squared should be the same as 8 squared plus 4 squared, but for good measure, we can go ahead and solve for these. 8 squared plus 4 squared is 80, and 80 squared is 6,400. So holy cow, not the same, not a right triangle. For C, A and B interchangeable. I'm going to use 5 for A. So 5 squared plus 13 squared. Does it equal 15 squared? I don't know. So 5 squared plus 13 squared is 194. And then 15 squared, 225. So these are not the same numbers. Not going to be C. For B, 4.5 plus 7.5 squared, does it equal 9 squared? So 4.5 squared plus 7.5 squared gives me 76.5, and 9 squared, 9 times 9, I know is 81. Close, not the same. So it has to be D, but let's just double check. 77.76 squared plus 5.82 squared. Does it equal 9.7 squared? Of course, the last one is all decimals. So 7.76 squared and plus 5.82 squared, 94.09, and then 9.7 squared is 94.09. Okay, so they're the same, they match up. Number 7, look at the diagram below. What is the length from point A to point B? So that's our longest side, that's our side opposite the right angle, it's our diagonal side, so we know that that is our C. So when we go to set up our Pythagorean theorem, we know we're looking for C squared. So A squared plus B squared equals C squared. Always write that formula down because it just helps to visually see what you need to do. So A, we'll say, is 34. So 34 squared plus 41 squared equals C squared. So let's say 34 squared plus 41 squared, and we get 2837, and then take the square root of that. So 53.26, round it up to 53.3.